Hey everyone, let's talk about physical states of matter. So today's activity that we're gonna do, and I encourage you to do something like this at home also, is to classify and sort these objects, these types of matter, into solids, liquids, and gases, okay? Once we decide if they're a solid, a liquid, or a gas, we're gonna talk more about how we figure that out, okay? So let's begin. Now, I want to talk actually before I go into that. First of all, gases are really hard to, you can't see them. So that's going to be something that I have very limited of here. But sometimes gases get trapped inside of things. So keep that in mind as we go through these items. Second, liquids. Liquids need a container. So that means all liquids, for the most part, are generally inside of a solid container. So when you're looking at these objects, think about what is it mostly, okay? And it's okay to differentiate between the two. So if you are gonna say the outside is solid, the inside is liquid, I'm good with that, okay? So back to the Topo Chico. Solid, liquid, or gas? Okay, if you said the main part of this is liquid, you're correct. But guess what? Topo Chico is carbonated. That means there's carbon dioxide inside of it. So have you ever twisted a soda or maybe even a Topo Chico and you heard the fizz? So that's actually gas escaping out of it. So there is gas inside of here, there is liquid inside of here, and then the glass is a solid. But if I were to say, what is this mostly? I would say it's mostly a liquid. Okay, next item. Let's do my little meditating gnome figurine. Is this a solid, a liquid, or a gas? All right, there's only one correct answer for this one. If you said solid, you are correct. We'll sort these as soon as I have some more room over here. All right, I have a Ziploc bag, but notice I can kind of push. So solid, liquid, or gas. If you said gas, you're correct. A metal spoon, solid, liquid, or gas? If you said solid, you're correct. Hand sanitizer, we all need it. I'm gonna use some right now. Why not? Look at that. What is that? All right, now this is a thick liquid, but this is a liquid. It takes the shape of its container, so it is a liquid. The outside is, of course, a solid. I don't think there's much gas in here, but maybe the space in between. All right, a candle. I'm gonna ask some questions about this candle. So right now it is a solid. What if I lit this? What would start happening to the wax? I added heat. What would start happening to the wax? Okay, if you said melting and turning to a liquid, you're correct. So this solid with heat added can turn to a liquid. This is an empty jug. An empty jug. Nothing's in here. So what's inside of here? I mean, I just lied. There's something inside of here. Gas. Remote control. Solid. Bananas. Solid. Mustache. Solid. What's inside of here? Liquid. All right, and the last one we're gonna do is this ping pong ball. Now, I don't know if you've ever seen a ping pong ball or felt it, but it's extremely light and it can easily bounce. So what's inside of here? If you said gas, you're correct. So yeah, it's a solid outside, but it also has gas on the inside. So let's sort these items. So I have my liquids. I'm gonna put over here. I didn't go over this, but it's honey, liquid. Hand sanitizer, this container, because I'm gonna show you something in just a minute. All right, gases. Actually, let's do gases on the side because I have very few of those. Solid, 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 solid. Right now this is solid. These are all solid. All right, gases. This is mostly gas. Oh, remote, solid, my bad. This, mostly gas. Ping pong ball, mostly gas on the inside. And another no, solid. Okay, liquids, solids, gases. So this is classifying. Classifying is when you're sorting items. I sorted my liquids, separated them from my solids, and separated them from my gases. Now, notice there's a similarity between the liquids and the gases. In order to keep the liquid and the gas, it needs a container. So it has a container that's holding it, okay? Now, gases can just go all over the place. So if I open this up, whatever gas was in here is now released into the air, okay? I could squeeze this and get the gas out of there. So gas is kind of crazy. It goes everywhere. Same with this. I can just pop it. Now there's no gas in here. It's around me. Reminder, water vapor everywhere around me. Oxygen is what I breathe in. I exhale carbon dioxide. Those are all gases that I cannot see but are all around me. So gases don't really they have to be held into a container, but as soon as a container is open, they go everywhere, okay? Liquids, they do keep the shape of their container, okay? And I'm gonna show that. I'm gonna show you that in just a minute. I'm gonna clear everything off here. It's gonna be crazy, so I'm just gonna dump it on the ground, and I'll have to clean it up later. But I'm gonna show you how liquids take the shape of their containers. But before we do that, let's talk about some characteristics of each of these. Solids have something called a definite shape. They hold their shape. This banana is curved. This spoon is circular with a long handle. It's not going to change. It keeps its shape. It has a definite shape. And it also has something called a definite volume. So it has a volume that I can measure, okay? And it stays the same. Liquids. Liquids take the shape of their container. So if I poured this honey into this container, it wouldn't look like this. It would fill up the bottom of this container. So liquids take the shape of their containers, and they also have a definite volume. So they have a certain amount of volume. And gases have no shape, no definite shape. I mean, look around you. I don't see a shape, okay? And they also don't have a definite volume. So we can't really measure that. So gases are just kind of crazy. And now I'm gonna show you how liquids take the shape of their container, and then we'll be done. All right. Oh my God. Moving these, I'll be a little more careful with these ones. Okay, I think I'm gonna kneel down. And I'm gonna come a little closer. Oh my God, danger. Okay, here we go. Now, notice, I have a certain amount of liquid in here. I didn't actually measure. No, I should measure. You know, let's fix this. Okay, so this, I poured too much in here. So we're going, and I don't have, you know what? Here. Empty container full of gas. Gas, goodbye gas. I'm gonna pour a little bit of this in here to get an accurate measurement, because scientists should accurately measure. Pour a little more in there. Okay, so I have about 225 milliliters in here, okay? You're not gonna be able to see that, so I'm sorry. It has what I told you, the 225 milliliters is its volume. So this is how much space it takes up. How much space it takes up is 225 milliliters. That's its volume. Now, it's going to change its shape. It's going to change its shape when it enters these containers, but its volume will stay the same. So let's go ahead and pour. So notice this one looks pretty full. All right, I'm just gonna check. Okay, 225 milliliters. Volume doesn't change. But now, look at it. Doesn't this one look half full? Because it takes the shape of its container. Same amount of water, takes the shape of its container. Final one. Again, let me check the volume. And again, 225 milliliters, same amount of water, none of it escaped. Now look at this container. Looks even less full. But didn't you just watch me pour the same amount of water in every container? So it does take the shape of the container it's in. This one looks like it's less, but it's not, because I'm gonna pour it back into the original container. And now I have a full container almost, okay? So that's your little lesson on solids, liquids, and gases. Reminder, classify means to sort into categories. And I hope you learned a little bit and enjoyed my bike in the background. Bye. Oh, actually, we have a visitor. Solid, liquid, or gas? Solid. All right.